Hey, what's up YouTube? Welcome to part 3 of the TBS Caipirinha build log. And today we're going to be putting in the FPV equipment. Now the first thing that we need to put in is this voltage regulator. So that's the 12 volt voltage regulator for the video transmitter. And the first thing I got to do is figure out where this is going to sit. Then I'm going to cut out a space for it and solder it in. Okay, looks like we got a nice little pocket carved out there for the voltage regulator. Now, it's not perfect. It doesn't look perfect from the inside there, but as long as that's nice and flush, it's not going to be a problem at all. So I'll show you what we got to do next. Now we've got to solder these connections here. We've got to route this wire through the bottom, and we're going to cover this up so it doesn't fall out. Alright, here we are ready to solder. I got my iron set to 895F. I've got 6040 Kester rosin core solder. I love this stuff. My dad's been using this stuff since the 70s, and honestly I think it works better than the lead-free, but that's just me. It's also cheap. A 5-pound roll you can buy on Amazon for like I think 30 bucks. So it's not very expensive stuff. Don't eat it. You know, don't put it in anything you're trying to sell because it does contain lead. But it's cheap. It does a great job. So let's get this insulated. Now we got to turn on our hot air gun. Shrink this tubing down. Right, awesome. Now I got to do the next connection. Okay. Okay, now we got it all wired in parallel. It's a little tangled, but that's not a problem because this is going to be running through channels inside the foam anyway. So let's get this put back in place. Alright, the next thing we have to do is wire the harness for the video transmitter. I'll show you how to do that next. Alright, so now that we got the power connections done, we need to do the output side. Replace the plug that was on there with this one for the video transmitter. Just got to quickly solder this all together. And it looks Okay, we got both of these done. Now we can start thinking about how we're going to route the wires through the fuselage. So before we do that, let's go ahead and properly affix this voltage regulator. Stick that in there, take a square of tape. Make sure that everything is properly seated. Just lay a piece of tape over it. Right like that. So now that we're doing some wire routing, let's leave these because we're going to install the current sensor before we put it through the fuselage. This guy, however, this guy can go, and I think we should do it underneath the ferrite ring. So let's poke a hole through. That comes out the top of the battery mounts. There's our connector coming through. Sure we got all of this tucked back where it belongs. There you go. There's the other end. Now the next thing we need to do is route it through. Alright, so now we need to route the video transmitter power wires. I lengthened them a little bit so they'd reach all the way over to the pocket where I'm going to stick it. I should note, though, that this channel, I cut it with an X-Acto. This was not pre-cut. I'm sorry I didn't film that. But, yeah, it's just a very simple run an X-Acto through the foam and then stuff the wires down in there. Helps if you have a screwdriver available just to have that extra point to push into your foam without pushing the foam itself. Okay, now I need to connect the connector back onto here. Alright, there we go. So I've got the Video TX right here. Alright, so I've got the Video TX right here. Power leads plug in right like that. Then we've got to find or build or modify right here a place for that to go in. Now I like the place that this is already because it's far away from my receiver gear. Need just a little bit more length. See if we can sneak a couple more millimeters of wire over. Okay, good. Alright, the only problem that we're having is that we need to, well, first of all, that's pretty much backwards. Well, this is going to be interesting. there. Still too big. Alright guys, so here's what I am going to do. I'm going to take this. This is the transmitter cutout. We could either CA that back in and just go right there for the transmitter, which honestly is sideways. I think it looks sloppy. Or we could CA it back in and make our own cutout, which is what honestly, I think that's exactly what I'm going to do. So let's find where that goes right there. Or much better, actually, I think, is this orientation. Yeah, I like that better. So I'm going to glue this in. I'll cut that out. I'll show you guys how to do that. Okay, so we need to mark out how big that is. Just going to say right about there. So a very easy thing that we can do is just take half of that plug out that we put in, because we're not going to need that bottom half of it. Remember, just the bottom half. Man, I could really go for a hot knife right now. Alright guys, so after much ado I'm back. The hot knife turns out to be a pretty alarmingly difficult thing to make work. It does a really good job cutting, but getting it to continue doing that cutting properly is kind of annoying. Leaves a great edge though. Makes the foam look real nice and clean, which is always awesome. Still got some uncured CA in here, mostly because I didn't check to see if all the pieces fit properly before I glued that part in that we ended up taking out anyway. So remember, let that be a lesson to you guys. Make sure to check more thoroughly than I did. Right now I'm working on removing all that CA. Excavating all the foam out. Alright, that's starting to look like it's going to fit. A little bit more work to do. There's always some more that can be cleaned up, fixed up. Always something to work on. Alright, after much effort, that's in there pretty good. And we're going to leave, actually I'm going to cut this heat shrink. Alright, I got that in there real good. But I'm going to cut the heat shrink off of the heat sink on the video transmitter because it gets warm. Right, and this heat sink is useless if there's no airflow over it. And this is an aircraft, so it's not like it's going to be needing a fan or anything. It's moving through the air on its own. We're going to make sure also that when we tape it in place, we're not going to put any tape over the heatsink fins, because that would defeat the entire purpose of what we just accomplished. Alright, now I need to start getting the wiring harness in there to make sure that everything fits. Here's my OSD that I had set up for bench testing. But I am going to remove the wire harness and I'm going to put it in there. So here is the input to the transmitter, the video input to the transmitter. Let's get the wires that we don't need out of the way. Let's get the video camera out of the way. OSD out of the way. GPS out of the way. Okay, so this is the only one that we're going to use right now. This is the patch between the video camera, the OSD, and the transmitter. So let's plug that into the transmitter and just make sure that we got everything in place the way that it should be. Okay, we got to carve out just one little more thing. Extend this down. Open that out. Beautiful. So what I'm going to do right now is I'm just going to take a couple of preliminary bits of tape, use them to hold in the video transmitter. Okay, cool. So we've got all this in place, and we will get these wires down as soon as we're going to do a few more things. We're going to put the OSD in place. We're going to carve these guys underneath the foam, the transmitter in the eagle tree, or the receiver rather, in the eagle tree. And then we're going to put one or two more things in place, and we'll be getting pretty close. Okay, so now we need to focus our attention on the flight camera. The flight camera is going to be separated from the GoPro. It's going to be this one right here. Because the GoPro 3 from the USB video out, anyway, has a 0.4 second latency. So the problem with that is 0.4 second latency means that it takes 0.4 seconds for the information to be encoded by the GoPro, sent out to the video transmitter, and then to get to your goggles. The very big issue with that is this plane can probably travel about 20 feet in 0.4 seconds. So if you're doing any kind of proximity flying, that latency can get really, really dangerous really, really quick. So this is actually super easy to install. I cut some slits to make it fit, and all we really need to do is plug this wire in here to the video out and power in portions, and just push it down right into that nice already existent foam cutout. Make sure that it's seated properly. See, we do need to cut a little bit to get it seated all the way down. Try not to cut all the way through the bottom of the plane. You don't have a lot of thickness to work with here. Okay, there's that. The great thing is we're not doing anything else with this channel here, because this is really only going one place, so we can actually start taping the wires down, doing some cable management while we work. So what I'm going to do is I'm going to take a strip of this tape, and I'm going to cut it half width, because we really don't need an entire piece of tape just to cover a wire channel. Okay, let's make sure to straighten up the edge so it looks nice and professional. Okay, here we've got our piece of tape, so let's start this cable management process going. Tuck the wires behind here. So I find that it's easiest to start from the distal or the furthest away end and work to the middle. Cut that excess off. Okay, there's that. These are going to hang out on top just for now because we're going to install, first of all, we're going to install the OSD and the Dora board over here. The GPS is going to be on the other side. And we want to place the AR7000 with the 7010 rather, excuse me, and the Eagle Tree Guardian inside the foam. So we're going to do that. If we can cut the foam and not cut any wires, it'll be an interesting engineering challenge for me. Interesting technical challenge. So this is our main board for the OSD, and that can plug in here. Kind of get those cables stuffed down. Just start getting them managed. You don't have to worry about finishing the cable management for a little while. Here's what we're working on here. Just getting this. So here's what we're working on here. Just getting this. So here's what we're working on here. Just getting this OSD in place where we want it to be, so we can get the tape over it and get everything set up. So I'm going to place the GPS over here, and in order to get the GPS, get it some optimal reception, we're going to want to use copper tape, and I will show you guys how to do that, how to shield everything out with copper tape right now. Okay, so there's the GPS antenna, and basically the whole idea of this OSD is it gets its airspeed and altitude data via change in GPS coordinates over time. So we want to make sure that that is as accurate as possible. One of the ways that we do that is by eliminating all the RF interference we can. And the way that we do that is we insulate the bay electromagnetically with copper tape. This stuff is super simple to use. Just cut a little bit off so it's square. There we go. Try and figure out how much we need, roughly. And then cut it. And now I should mention that we do not want to put it above the GPS because basically that would block the signals from the satellites that we are trying to receive. So that would be stupid. It would get us further away from our goal, which is to get accurate data about the position of our aircraft and how quickly that position is changing. So this is actually very necessary, in my opinion, if you're flying 2.4 radios, because the third harmonic, it's either the second or third harmonic of 2.4 is 1.3 gigahertz, and the GPS satellite band is 1.2 to 1.1 gigahertz. So it is very, very close. I would not chance leaving a satellite system unshielded if it's going to be used with a 2.4 transmitter. If you ask me, this copper tape is just so cheap and so light, there's really no excuse not to use it. So you can go ahead and trim off the excess copper. Having flashing around the top is not going to do anything for your plane, but make it look sloppy. Okay, now that we've got that stuck down, and the wires are extended out, and we got it all sealed up with the RF shield tape, we are ready to close it up with some of the strapping tape. I will show you guys how to do that. I don't really think I need to explain it. You just put a piece of tape over the hole. There is a little bit of unused space, but I'm sure that I can find some sort of alarmingly crazy device to put in there in the future. A little bit too shy. So if it were me, and it is me, I'm going to tighten this tape as much as possible. Stretch it real good, just so that it maintains a great seal above the GPS receiver. And we can also start working the cable management in distal to proximal, just like last time, outside to inside. Make sure that all the wires are in the channels properly and not protruding out when you lay the tape down. Okay, good. That's almost an entire side completely done, but I did want to show you one more thing. That there's the satellite receiver right there, and I'm thinking that because there is no such thing as too much RF shielding, we should make a little bit of shadow for it so that it doesn't get any interference from all this radio transmitting stuff that we have on board. Remember, the difference in crashing your plane due to lockout from 2.4 or surviving to fly again might be the difference of a square or two of tape. There is no such thing as too much shielding. But every time you add shielding, you are gaining the probability of getting better range, because your Spectrum radio will be able to hear your transmitter more easily above the noise, the other noise, because it's going to be muffled, if you will. And like I said, every time you add a piece like this, that could be the difference between your plane in a tree somewhere where you can't find it, or your plane coming right back to your hands. So it's important stuff. Don't skip it. Alright guys, so I stripped out that awful Hobby King regulator. Now let's see if we can find right here the new voltage regulator. It's not these are the stabilizing caps. Let's follow this all the way down. This guy right here, this little tiny chip, is a voltage regulator from Polalu Tech or Polalu Electronics, and that provides 1200 milliamps of current to my VTX and my camera. So this is going to be awesome. I am really excited that they did that. Really happy about this. This is an awesome design, and it is so tiny and so easy to install, even in the smallest places. Like if I was doing my MQX again, this is how I'd get one cell power to my video equipment that ran on 12 volts, because that is just so simple and so tiny. So I've got this is a LC filter that I built in my other video. I just basically consolidated it. I built the second one and consolidated the size a little bit, so it's not an issue to get that whole circuit in here. So I'm just going to put this stuff together and finally get everything taped in place, and that should provide adequate voltage regulation and nice clean power for my camera and transmitter. So we'll see how it does. You know, I'm really impressed with how small they were able to make such a powerful regulator, and I think it was like $3 from getfpv.com. So it's a great deal for that amount of current. I mean, that's actually cheaper than the Hobby King one, believe it or not. Hobby King one was like $7, which I have, quite honestly, incurred the wrath of a few flyers. Few FPVers have been really upset. Oh, you bought from Hobby King. Well, they have some good stuff, and they have some really bad stuff. Most of the problem is that figuring out what the quality that they have is. For example, this is, I did some step down stuff with it, and it produces a really clean signal for step down, but not for step up. So they lied about that. Alright, so I'm going to get the rest of these cables managed, and then we'll flip over to topside and we'll finish up the wiring there. Alright guys, so we're back on the transmitter side, and as you'll see, I finally got my Fat Shark circularly polarized antennas in place. About time I got the adapters, and now all I've really got to do from here is finish up that cable management and test everything. So I'm going to start working on that right now, and I'll let you guys watch how I do it. Alright guys, so here's most of the finished cable management. As you can see, the periphery is pretty clear, but I've still got all this junk in the middle. So what I'm thinking about doing is making a little nacelle that comes over here and stretches probably up to the GoPro. And I'm going to see what I can figure out, and I'll show you guys how to put that in. Alright, so here's the finished aircraft. I did not decide to go with the nacelle. Now, the more that I think about it, the more that I feel like it's just going to be a lot of extra junk on top that I don't need. But let's plug this in and let's see if I can get the FPV set up. I think it's going to look pretty good. Hey, what's up, YouTube? Looks like I did it. I got my TBS Caipirinha all set up, and I've got the video feed patched into my TV over there. So it's working pretty well. It's working pretty well. I really like the way that this tiny OSD has worked out for me. So I'm going to go give it a try and see how it flies. I think it'll do pretty well. Enjoy, guys. If you like this video, don't forget to rate, comment, and subscribe so I can make more for you.